Okay, we're going on now to topic 5.7, which is the sum or difference of perfect cubes. So as we look at this right here, we see this is the sum, and this is perfect cubes. I guess we had a little error there. So when we factor the sum or the difference of perfect cubes, there is a recipe that we follow. And I'm going to illustrate the recipe here. And that is to make a parenthesis for two terms and a parenthesis for three terms. And it's the same for the difference. A parenthesis for two terms, a parenthesis for three terms. So that's the first step of the recipe. Next step is whatever sign is there, separating your two terms, that goes here. So this one goes there. So once again, a parenthesis for two terms, parenthesis for three terms, and whatever sign is there goes in your two terms. Now, the next part of the recipe is the middle sign in your three-term parenthesis. Well, that middle sign will be the opposite of this sign. And now you fix the signs for the recipe. Now, the next step is take the cube root of a to the third, which will be a, in both places. Take the cube root of b to the third, which will be b. Now the next part is you square this first term, that goes right here. You multiply these two terms together, and that gives you an AB. Now you might say, normally when you multiply these, this would be a positive, but according to our recipe, you have the negative there, and that is correct. So that's a little bit out of the normal multiplication. And then you square your last term. So this is the recipe. Step one, parenthesis for two terms, parenthesis for three terms. Next, place your sign in the parenthesis for two terms, depending on the sign that's there. Then fix the sign in the middle of your three-term parenthesis. It's the opposite of this one. And then square your first term. Multiply these, square this term, and there you have the recipe for factoring the sum or difference of perfect cubes. Now you'll notice the results are pretty much the same, it's just the signs. So here there's a plus, there's a minus. Here there's a minus, there's a plus. Now it takes a little while to master that, but let's use it now in doing this. So we see we have the sum of perfect cubes, and there's no common factor that we could factor out. We have to always remember that. We're going to put a parenthesis for two terms and a parenthesis for three terms. First thing we do is put a plus there, and then opposite sign there. In fact, we'll set them all up. Parenthesis for 2 terms, parenthesis for 3 terms. This sign will be negative, this sign will be plus, it's opposite. Parenthesis for 2 terms, parenthesis for 3 terms, this is a plus, and this will be a minus. Now we take the cube root of x to the 3rd, which is x, the cube root of 125, and again, you may not know that that's a perfect cube, but it is. And we'll get to that part later. Let's just do this. Cube root of 64 is 4t. Cube root of 1 is 1. Cube root of 8 is 2. Cube root of 27 is 3. Y. So we've taken the cube root of each of these, and again, we're following a pattern. Now what we do is we square this first term, multiply these together, and then square this term. Square this term, multiply them together, square this term, square this term, multiply them together, square this term, and I believe we are correct. Now again, the enigma of having, when you multiply these, the opposite sign and what you would expect, that's part of that original recipe of what we had said. All right, we'll try some more. Okay, some more examples. Again, we want to set up the recipe for the sum of perfect cubes. The difference, here we're going to do some factoring first. And so a parenthesis for 2 terms, a parenthesis for 3 terms. Now here we have to factor out a 6 first. And we get 1 minus p to the 3rd. So here we're going to have to include the 6, but parenthesis now for 2, and then parenthesis for 3 terms, and parenthesis for 2 terms, and parenthesis for 3 terms. Now let's get our signs. So in the parenthesis for 2 terms, a plus, and then opposite sign there, a minus, opposite sign there, a minus, and opposite sign there. So now the cube root of each term, and then the cube root of 1 is 1, p. Cube root of d to the 3rd is d, and the cube root of this is 0.2. Because 2 times 2 times 2 is 8, and we need 3 decimal places, so that works. Okay, now the next part of the recipe, square this term, multiply these two terms together, and square this term. Square this term, multiply these together, square that, square this term, multiply them together, square that term, and there we are. So in this section of factoring the sum or difference of perfect cubes, it's all built on a recipe that you're pretty much going to have to memorize. Or if you're allowed to use notes, have that as your pattern, and then through practice, you probably won't need your notes anymore. It's nice to have something a little easier for a change, but part of it is the recipe. Again, as you look at this, is there a common factor? Well, yes, we could factor out a 3. And then here we could factor out a p. Okay. Now, following our pattern, a parenthesis for 2 terms, a parenthesis for 3 terms, parenthesis for 2, for 3, and then doing our signs. This will be a plus. Then over there, the opposite. This will be a negative. Over here, the opposite. This is a negative. Over here, the opposite. Now, the cube root of a to the 3rd is a. The cube root of 8 is 2b. X. This is a little tricky. 1/3, so it's the cube root of 27 is 3. And then this is just q, and this is p. And the fun of this will be that, you can do it. It'll look a little challenging initially, but you can do it. And then in the next chapter, chapter 6, you'll see that you'll need to use this technique of factoring the sum or difference of perfect cubes. And you'll get to that soon enough. Okay, we're going to square that. Multiply these together. And square this. We're going to square that, multiply these together, and then square that. And square this. And as I say, once you catch on to the recipe, it's sort of fun, I think. Now in these next few, kind of tricky things, but let's see what we can do. So here we see there's a common factor of 10. And then this gives us 125, t to the 6th, plus s to the sixth. Here we see that we can factor out a 3m squared. And then we get m to the third plus 1,000. Now, number 15, when I first did these, and by the way, I did these ahead of time, so I saw sort of what was going on. This is actually the difference of perfect squares. Let me say that again. This is the difference of perfect squares. You can factor this into its conjugates, which will be x to the third plus 1 and x to the third minus 1. Now we have the sum and difference of perfect cubes. This one was a little tricky. So we'll get to that one in a little while, but let's do some of these. And again, we need the 10, parenthesis for 2 terms, parenthesis for 3 terms. Whatever side is there goes here, and then opposite. And again, 3m squared, parenthesis for 2 terms, parenthesis for 3 terms. And we'll get to this one in a little bit here. Put our plus here and minus here. Now, hopefully, depending where you are in the film, you are doing these on your own and seeing if you, in fact, are getting the results. But then you can use this to check your work. So, the cube root of 125 is 5. And the cube root of t to the sixth is t to the second. So the cube root of that would be s to the second. So that part was a little tricky. Now we square this and get 25 t to the fourth. Multiply these two together, and we get 5 t squared s squared. And you could have the order of this reverse. That would be okay. And then s to the fourth. That is, we're squaring that term. Here we're getting m plus 10. M squared minus 10m plus 100. And then here, depending how you set it up, parenthesis for 2, parenthesis for 3, another one for 2, another one for 3. And this will be a plus, this will be a minus. This will be a minus, and this will be a plus. And then it's just x1, x squared, x plus 1. This will be an x, a 1, x squared, x plus 1. Wow. So this one was a little tricky. But, once you realize this is the difference of perfect squares, factor it into its conjugates, and then treat each of these differently, and they just follow the pattern. Now, what they've given us here is an equation to the third degree, and another equation to the third degree, and you're wondering, what would be the strategy to solve this? Well, a little later on, you're going to be dealing with radicals, and I'm not sure whether they're going to use that technique or another, but the easiest way to solve this is just transpose the 1,000. It becomes a negative 1,000. And you have t to the third equals a negative 1,000. And then just take the cube root of this side and the cube root of that side. And the cube root of t to the third is t. And the cube root of that is negative 10. Again, I'm not sure if you're going there in the course or how they're going to treat this. That's how I would. And then for number 19, again, you're going to divide both sides by 6. You get x cubed equals 8. Now take the cube root of this side and the cube root of that side. You get x equals 2. I've left out a few that were kind of challenging, but they were similar to the one we had done before. So good luck with this section, and I think it's nice to have something a little easy, but you need to pretty much memorize the recipe for factoring the sum or difference of perfect cubes.